All right. Now, like I said, since I don't have the book, we will have to go at it from yeah, just come on in whenever, that's fine. I'm surprised you didn't say that.
Were you late too?
No, I was here on time. I'm always here on time. All right. Now, remember me telling you that there's two types of problems in statistics. There is data-driven. I'm going to get up and then there is the frequency distribution. That's what I call data-driven. That's like test scores. Now, we're going to go through and we're going to do a data-driven problem today, and we're going to do frequency distribution. We're going to do both. And basically, on your test, there'll be some on there. But you got to find the mean and the standard deviation. And that's why I'm going to do both of them today. And that way, y'all will all understand how to do it. So, with that, we're going to put some test scores up there. And of course, most of y'all, 90% of y'all, will be able to find the mean without any problem. Let's go with 72, 80, 80, 85, 90, and 92. There's our test scores. And then over here, we're going to go 90 to 99. There's 4 people that made an A. 80 to 89. There's 5. 70 to 79 is 6. 60 to 69 is 3. And 50 to 59 is 1. So there's your two types of problems. Now, of course, they don't say the same thing. That's not what I'm trying to tell you. But they're data-driven, and then there's frequency distribution. Now, with the data-driven, I'm going to go to the Excel spreadsheet, and we're going to find, no sneezing in class, we're going to find the different things that we need, whether it be, and the only reason I'm using the Excel spreadsheet is so I can get everything on one screen, and if I tried to write it, you could forget it. All right, so hold on, oops. Trying to do 2 things. So me, I can't do it. 2 things at one time. Hold on. All right, so we'll call this X, and I'll fix it where y'all can see it in just a minute. 72, 80, 80, 85, 90, and 92. And then I'll go way down here, and I'll do 90 to 99, and 80 to 89, 70 to 79, 60 to 69, and 50 to 59. And that's 1, 3, 6, 5, and we'll call this grade.
We call this get count. And over here, and let's move that up to about 20, and I keep staying for him. Okay, there. There. Now, we're going to write a list of things over here that you're going to need. These are the important numbers that you need when dealing with statistics. There's the mean, the median, mode, range, mid-range, and the variance, and the standard deviation. Now you don't have to find that with your frequency distribution. This is just with data driven. Okay? The mean is also called the what? Average. It's also called X bar. It's supposed to be X with a bar over it, but it takes twice as long to do that in Excel, so you can put quotation marks around that. X bar, put quotation marks around that, and then put an X bar, X with a bar on top of it. Okay, can you stop disturbing class?
Yes.
Good God. How am I supposed to concentrate? All right, so what do? You add up all of your numbers. So you take your handy-dandy auto sum right there. See that little sigma? Click on that. Highlight all the numbers. And then divide, put it up here. And divide by, how many numbers are there? 6. Me. And if anybody in here has taken a class before, you've figured up your average. That's how you do it. Now, I'm not going to insult anybody's intelligence by going over that, but you add them up and divide by how many there are. Median, not media, median. When I say before this class met, if I was to walk up to you and say, when I say the word, you tell me the first thing that pops in your head. Median. Why do you think of middle? Middle of the road, median, concrete median? That's usually what people think of. Only if you're weird, you think of numerical middle. But most of the people think of median as the middle of the road, the concrete median in the road. The average, the median, and the mid-range are all distinctive of the center of your data in some way or another, either mathematically or by the tendency of your data. Tendency of your data is different from numerical. The numerical middle is the mid-range. In other words, you got a number line with 72 on the low end and 92 on the middle is the mid-range. That's the mathematical middle. The closer the median and the mean is to the middle, the closer your data is to being good data. Okay? So median, how do you get the median? Well, we'll write it out here. With odd number, when n is odd, let's say when n is odd, you just take the middle number. Okay? When n is odd, you just take the middle number. All right? What about if n is even, like we got? If n is even, you take the average of two middle numbers. So, I'll take my handy-dandy highlighter and highlight that. Yellow, my favorite color. And then those two, I'm going to highlight yellow. And I'm going to come over here and I'm going to say equals, meaning The equal sign to Excel means, okay, I'm fixing to put in a mathematical formula. That's what it means. And I'm going to put parentheses, this number, plus this number, and I'm going to divide that by 2. And there's your median. Now that median I'm going to take this blue marker because I can't stand the red marker. That median is right there. That number is right there, and that's going to help us later on when I do some more numbers and we find in the 5-number summary, which I'm not going to find 5-number summary for 6 numbers. That's kind of like putting 5-gallon gas in a full gas tank. I mean, you don't have enough numbers. Okay? So, mode. What is mode? Remember most. Most, the number that shows up what? The most. So you put over here MO for mode, MODE equals MOST. So whenever you see the mode, remember the most. Now, can you have more than one mode? Yes. If this one, the mode is 80. Why? Because it's the number that shows up the most. What if we had 2 80s and 2 85s? Then 80 and 85, 80, 85. Whatever shows up the most. Now, if there was a 70 in there and it showed up 3 times, then 70 would be the mode. Is the mode important? Not really. It's probably the least important of all of them. I don't really care about the mode. The homework and the test will ask it, but I don't really care about it. Yeah, if there's no mode, you put none. You put NA, you put not applicable, DNA, does not exist. You do not put what? 0. Do not put 0 because you'll have some smart aleck teacher mark it wrong because there's no 0 in the list. Okay? Even though 9 times out of 10 that teacher knows what you're saying, put nothing, put none, nairn, does not exist. Range. Remember the range is the highest minus the what? Okay, so let's go over here and put range is equal to the highest minus the lowest. So that's pretty simple. That's 92 minus 72. You might need to get your calculator out. 20. Mid-range is mid. If you remember in algebra, the mid-range is the same as the mid what? Midpoint. It's the middle. And that is parentheses, highest plus lowest divided by 2. So I'm going to take my handy dandy equal sign and I'm going to take the highest, parentheses, the highest plus the lowest divided by 2. Or you could say, what's the difference between 92 and 72? 10, Hubert. That's right, class. And half of 10 is what? 5. So add 5 to 72. What do you get? Okay, well, that's not right. What did I say?
Yeah, you said 10 is 20.
Oh, okay. I'm sorry. Half of 10 is what? Half of 5. Oh. Thank you. Half of 20 is 10. 10 added on to 72 is what? You can do it that way if you wanted to. 92 minus 20. 92 minus 10 is 82. Thinking of 3 things at one time. Now, these 2 right here are very similar. The variance is a mess, but the standard deviation is equal to the square root of the variance. Okay? So if you can get the variance, then all you got to do is take the square root of the variance, and you got your standard deviation. And then I'll explain what all this stuff does. All right. Now, the formula for the variance is equal to the summation of x minus x bar over the standard deviation. I meant not the standard deviation. N times n minus 1. I think that's supposed to be quantity squared. There we go. All right. So the summation of x minus x bar quantity squared over n times n minus 1. No, not times n minus 1. I got it mixed up with another formula. Times n minus 1.
And just n minus one?
Yeah, just n minus 1. So, what is x minus x bar? What does that mean? Well, that means you got to take this number and subtract what? What's x bar? The average. So I'm going to have another column. So we go over here and we put x minus x bar. So the first one's going to be 72 minus what? 82.5. I mean 83.16. That's right. And I'm going to lock that for those Excel people. I'm locking it F4. And check your numbers. Should be your numbers for x minus x bar. And I just did this right here. So I'll take my handy dandy highlighter and this right here. That's not a highlighter, Hubert. I hit the wrong button. Sorry. I want to color it green, no aqua. Alright, this right here is right here. Okay, x minus x bar. And then what are we going to do with x minus x bar? I'll take my handy dandy highlighter, color that green, and that's going to be this box right here. We're going to take each one of these guys and we're going to what? Square it. So x, parentheses, x minus x bar, close parentheses, raised to the second power. So that's equal to this guy raised to the second power. Now what do we do? Take our handy dandy highlighter. What do we do with x minus x bar quantity squared? What does that sigma mean? I'm sorry, you got to speak up. Add it up. Add those numbers up. So we take our handy dandy summation bar. Oops, sorry. Gotta put it down here first. Summation and add up all those numbers. And that is the numerator for your formula here. So our variance is equal to this number, 272,833, 272.833 divided by n minus 1. Well, I'll do n minus 1 for you. That'd be 5. So the variance is equal to So here is our summation of x. X minus x bar quantity squared. That's that. And I think now let me move that. Let's try this. Oops. Well, I can't move one for the other, so hold on. I gotta fix this because this will drive me crazy, so hold on. I'm a little bit OCD when it comes to this stuff. There we go. So now our variance can't spell is equal to this guy divided by 5. Now variance, that's nice, but I don't care about the variance. The only reason I care about the variance is because I can get the standard deviation. And the standard deviation is the square root of this number. Now how you do square root? You just raise it to the 0.5 power, 1/2 power. So equals this raised to the 0.5 power. There it is. And that's the number that we really want. Okay? Now, what does the variance tell us? Well, I'm fixing to go to another screen here in just a minute. But I wanted you to see what we were doing with the numbers. This is data driven, so this is like test scores. So you know how to get the all these numbers down. You know how to do that with this. But what is this? And I'm going to go into another page, and I'm going to say text. I'm going to put in big letters. What is the average? Now, when I ask that question, a lot of people go, oh, well, it's the number that you get when you add them all up and divide by the number. No, that's not what I want. What is the average? What does it dictate? What does it imply in mathematics? Well, not many people can tell you the answer because they don't know. Let me show you an example of what the average is. Take our handy dandy black marker, and we're going to draw a straight, try to draw a straight line. Yeah, straight line black. And we're going to put a little grid here. All right, we're going to make a bar chart or a histogram, whatever you call it. We'll make a histogram. And we're going to draw, let's make this 5, oops. Let's go with 5, 10, 15, 20, 25. Five increments of 5. And let's say we got let's put some, easier for me to draw a rectangle like this. And we're going to color rectangle. Let's say this first one goes right here. 5. And the next one, oops, messed that one up. Next one is at 15. And then the next one is at 5 again. And the next one is at 20. And the next one is at 10. I'm thinking. And the next one is at 10 also. All right. Well, anything in life is easier when it's level, right? I mean, if you're pushing something or if you're trying to build a house or whatever the case may be, you want everything to be level. Now, right now, this isn't level. So what I'm going to do is I'm going to change my color of my, if I can do this, I'm going to try to do it. Change it to blue. And I'm going to take this piece right here, which is 5, and I'm going to cut it off, and I'm going to put it right here. Everybody with me? I took that off, and I put that right there. So I'm going to try to delete that. And I'm going to move this, what? Everybody see what I did? And then, well, this is not working out like I wanted it to, so I'm going to move this down. There. And then I'm going to take this guy right here, and I'm going to cut it off, and I'm going to put it right here. With me? Now, what did I do to my graph? I got it from being a variant graph to a uniform graph. With just moving those two things, I got, and I'm going to take my handy dandy straight line maker, and we'll color it dark hunter green or whatever green that is. And that line right there is level, meaning there is no variance, meaning that it's uniform. And that number is called your average. That's what it's called, the average. So your number, the average, is the number that says in the whole class or in your grades that there is no what? No variance. Zero variance. Zero variance means the average. Now you can describe what the average is. The average is where the number that represents no variance in your data. Now, speaking of data, let me go back. The average is the number that represents no variation. I made that up. All right. Now, let me go back and let's look at this. Now, there's our graph. Look at the graph. We're going from here to here to here to here to here to here. All right? These points right here and these valleys represent what? Change or variance, right? So you got data going up, down, up, down, up, down. That's variance. Your variance is going all over the place. I'm going to type in a word here. And the reason I'm going to type it in is because hopefully it'll be neat. I'm going to wind up this every time to pull up something. Slop versus tight. Now I get ridiculed about bringing this up. Some people are like, what is he talking about? All right? Anybody that has any mechanical inclination if you put an axle or any type of axle or rod in a bearing is what lets it roll like a ball bearing. Think of your axle on your car. That axle just don't sit and just turn and turn on a piece of metal. It can't. It will cut itself. It's like a lathe. It'll cut itself. So you have to have something between the metal and the axle. I wish. Hold on just a second. You got to have something to go there. What are you talking about here? Well, I'm going to show you. Go here, here, axle, and bearing. Just bear with me because I got something to, let's see, here we go. That's a good picture. Let me just go to images and see if I can find a good blown up picture. There's one right there. All right, there's your axle. Here's your axle, and here's your bearing. Now, of course, this is not a big axle and bearing, very small. But the whole point is, you see the bearing right here, and then of course your car, the rest of your axle would go around this bearing, and your axle would turn inside there. Now, if you got a bearing that fits onto an axle real tight, that means you have to take a rubber hammer and a piece of tubing and take it and put it on that inside race. The inside race is the inside circle. You have to put it on there and you have to tap it on. Now, that means that it's a tight fit. Is that good or bad? Well, with a bearing turning at 2,500 RPMs, do you want it to be loose or do you want it to be tight? You want it to be tight because that thing's turning in there and it's turning at a very high revolution. So if you have a bearing on there that don't fit and it's loose and you've got a 1/4 of an inch gap in there, it's going to last about 5 minutes and going to tear all to pieces. Okay? Because it's turning, it's going to sit there and wobble, and eventually that axle's going to get out and it's going to start hitting and start making all kinds of noises. All right? Slop, that means you have a lot of gap. Tight means that it's fitting on there good. The tolerance is very minimal. Now, what the heck does that have to do with numbers? Same thing. If your standard deviation is very big compared to your numbers, that means that your data has a lot of what? Slop. You got a lot of variance. It's moving all over the place. Now, if your standard deviation is very low compared to your data, that means that your data is what? Tight. Just like the bearing. Gives you a visual to go with the numbers. Okay? So, that's why standard deviation is so important. Because when you have standard deviation, and you have your handy-dandy normal curve or whatever curve you got, y'all impressed, aren't you? I figured you would. All right. I know, it's just awful.
So I said, it's like witchcraft.
There you go. When you draw a normal distribution, the middle of your normal distribution is the mean. Okay? And then, just like if I was to tell you, I need somebody to paint my house, and you're a painter, and you come to my house, and you say, well, I can paint it for $1,000, give or take $200. What does that mean? $1,000, give or take $200. That means $800 to $1,200 is going to be the estimate. Okay? Now, think about that with standard deviation. Your mean is your $1,000. Your standard deviation is your plus or minus $200. So, if I get a mean let's say a mean of $200 or $1,000 or 1,000. Okay, and I go down here and I put 1,000. Then my first standard deviation right here is going to be what? 1,200. And my second standard deviation is going to be what? 1,400. What am I doing on the right side of the mean? I'm adding, because the right side of the number line is what? Adding, Hubert. That's right, class. Okay? Now, if the right side is adding, what do you think the left side is? Subtraction. So here's your 800. That's very irritating. And 800 minus 200 is what? 600. And there is why the mean and the standard deviation, you're going to be doing this throughout the semester. After chapter 3, you're going to be doing this with pretty much, except for probability, you're going to be drawing this in chapters 3, 5, and 6, and 7. You're going to be drawing this. Besides probability, you're going to be doing this. And you got to know the mean and standard deviation. All right? Now, there's a rule in your book. I don't know what page it's on, but we're going to put it right here. It's called the Empirical Rule. And I always misspell it. E-M-P. I want to put an H in it. So, find it in your book. And you need to memorize it. The Empirical Rule. Anybody got a page number yet? It should be 3.2, 3.1, somewhere in there. I don't know if it's in there or not. The books usually have it. But what does it look like? Well, it's a graph, looks like this. And between the graph, you got a shaded area. And this shaded area is right here. Well, you just got a shaded area, yeah. There's a shaded area, and it has 95%, and it says 34% and 34% and all that. Is that what it says? If that's it, then you got it right place. That's it. It should have a picture and percentages all over it. That's it. What page? 137, somewhere in there. Look for the Empirical Rule. You need to memorize it. It will be on the test, and it will be on chapter 6 and chapter 5 and chapter 7. So you're not going to get away from it, just like you're not going to get away from the mean and standard deviation. That area right there is within 2 standard deviations. 2 standard deviations is what we call normal. My daughter is graduating high school, but when she was a baby, she called normal. And every year I say that, normal. All right? So it's normal, meaning that it's not unusual. Now, put that in the middle, and we'll draw 2 straight lines. I'm trying to draw this real pretty for y'all. Falls within 2 standard deviations. Now, I'm sorry, what?
Falls between 2 standard deviations of the mean.
Yes. Both ways. Now let's take our handy dandy straight line maker, and we'll do it in red. Right here, 3rd standard deviation. And 3rd standard deviation over here. So what would the 3rd standard deviation? Well, 3rd standard deviation right here would be what? 1,600. And over here would be 400. Now you need to know those also. Well, what's between 400 and 600? What's that called? Well, it's called something. It's called unusual. I'm going to take my handy dandy I'm going to put right in here, unusual. Same thing over here, unusual. Now, it's a very small amount. There. Because right here, you're talking about 34% and 34%, so 68% right here, right? 68% here. That's between the one standard deviation. Right here and right here is 68. I think this is 13.1. This is like 2.5 or 2% here and 2% here. That's why you need to know it. Now, what's on the very outside? Well, remember out. These called outliers. Dang old 6-foot second graders. Dang old 1800 SATers. The ones that, your 300-pound first graders. Outliers, not outliners. Outliers. It's a very small percentage, but it's outside what? 3 what? Then standard deviations. Now you use the empirical rule to tell you about your curve. So if you set up, what page you say this was on? 137? Okay. Page 137 and 138. So if you, on all the problems we're going to do from here on out, I'm going to ask you to draw this thing. And then you're going to tell me what's normal and what's unusual and then you can tell. But that's why you have to remember the empirical rule when you're drawing this thing. You have to remember it. Okay? And what is 2.5 plus 2.5? 5%. And that's the magic number. From these two guys right here, the unusuals, in some of your questions you'll be asked if something is unusual. All right? 2.5% plus 2.5% is equal to 5% or 0.05. 5% or 0.05 most of the time is called, determines if something is normal or unusual. If you have a number that is above, I'm looking for it, hold on, 5%, then it's normal. If you come out with a number less than 5%, then you're talking about unusual. Now, the reason I'm showing you this, unusual, can't spell it. You're going to have some homework problems, and those homework problems may have a find the mean and standard deviation, and then they'll ask a question and say, well, what if blah, 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 and you'll say, okay, well, that number comes out to be 10, and that 10% is greater than 0.05, so it would be normal. So you might be asked some questions like that in your homework, and that rule applies. If it's more, if you come out with a number, if you crank out the math, and you come out with a number greater than 0.05, then it's normal. That means it's in what? It's in this area. If you come out with a number that's less than 0.05, that means it's in here or in here. Okay? They don't ask for too many outliers, but if you are asked for an outlier, you have to throw in this last number here, 1600 and 400, and then you can tell if it's an outlier or not. Okay? So, that's why the mean and the standard deviation are so important. So let's do another one. Let's go back to our handy dandy Excel spreadsheet. And we will go down here and we'll type in a new series of numbers. X. And I'm going to just make up some. Let's go with ages. 17, 17, 18, 19, 19, 19. No, not 419. Old ass. 19 and 20, 21, 21, and 29. Women get up to 29, they don't get any older. All right, so how many we got? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Good, I want it odd. All right, I want you to go ahead and start finding all the information you can on these problems. And I'm going to pause the handy dandy. Can I pause it? I don't think I can. Somebody's got to remind me to. I need to start listing everything. Mean, median, mode, range, mid-range, variance, standard deviation. She bothering you? I call security on her. All right. So the mean, how many we got? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So we're going to hit our handy dandy summation bar. My dang old kids raised on dang old Blue's Clues. That's where dang old handy dandy comes from. That and SpongeBob. Dang old 11. Oops, I got divided by. Don't like that. Oh, God. And have a connection. I can do some things with it, let me tell you. All right, so that's our mean. So that's the middle of our curve. Yeah, unless you're doing homework or a test, it'll tell you to round it to the nearest hundredth or tenth or whatever. But for drawing the curve, I would use 21, and I would round the standard deviation up to the nearest whole number as I was drawing my curve. Because I'm not going to sit there and try to add 20.81 and 7.62 in my head. I'm not going to do that. Median. Well, this one's easy. All you got to do is count down 5. 1, 2, 3, 4, 5, and there's your median. We'll highlight that dang old yellow, depending on where you're from. And that one is yellow. Oops. Blame it. Sorry. I think I might as well quit. Right here is yellow. We'll do that guy. Mode, I really don't care, but I think it's 19, isn't it? Now, something else that will tell you how tight your data is the mid-range, the median, and the mean. Look at the mean and the mid-range. Pretty close. Now, what's not pretty close? Well, if your median or mean is 20, 21, and your median is 15 or 25, then something's going on with your data. You got some outliers in there somewhere or something. And we're going to do something in just a bit with this list. How many we got in here? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Well, we'll just make up some numbers. We'll see what happens when you throw an outlier in here. See what happens, and you'll see the slop start to form. Range, highest minus what? Mid-range is equal to the highest plus the lowest divided by 2. And there you go. There's your easy numbers. Again, the mid-range is 23. What's the mean? 21. The median's 19. So they're within 2 or 3 of each other. Pretty tight. So this is going to be x minus x bar. That's equal to 17 minus this, and hit F4 for those people that know what that means. Let me explain what that is in case you want to know. When you roll down in Excel, it takes the formula with it. If I don't lock that mean number, it's going to read for this box, it's going to read this number. In this box, it's going to read this number. This box is going to read that number. So I have to lock it. I have to lock it to that number right there. F4, Foxtrot 4, F4 locks a number. And the only place you need to lock it is right there. Put dollar signs around it. And that basically says for each one of these boxes, I'm going to subtract this number, not these numbers down here. That's what that does. And now I can copy it down.
So are you going to leave it at the 20.8?
I'll use that in every one of these. So you go back to your...
Standard deviation.
Well, this is x minus x bar. That's part of standard deviation, yes. Now, what do I do to x minus x bar? Square it. So I'm going to take this number, and I'm going to raise it to the what? Second power. Now check your numbers and see what you got. You should have some of the same numbers in your chart. If you don't, then we can mark it up as being a loser. Living in a ditch in a cardboard box. Now what are we going to do to all of those? Add them up. And that is the numerator for your variance. Numerator for variance. So we just have to divide by what? N minus 1, which would be 10, right? Well, you don't have to do that on a calculator. Why? Just move the decimal one place to the left, be 18.16. Everybody should know that.
Sure.
Y'all don't know that? Y'all don't know that one? Let me show you. Huh? You must have had a good teacher last semester. Who was your teacher? Of course. All right.
What did he teach you?
I taught him 103. 103?
Yeah.
103. What do you mean, what did I teach him? What kind of question?
This was the second time in your class.
Oh, yeah. Yeah, both of this student, Miss Young took college algebra. You took 103. What did you take? College algebra. Anybody else? 155. No, that's 110. College algebra is 110. You kind of lost. No, you're not lost. You're Jan. I'm Hubert. All right. When you multiply, for those of you that don't know the trick, dang old. When you multiply by bases of tens, 10, hundreds, thousands. When you multiply by anything that's got a lot of zeros in it, especially tens, 100,000, you count the number of zeros and you move it, that number places to the right. You move the decimal, that number places to the right. So if you multiply 22.6 times That hurt my feelings. You watch that. Move the decimal 2 places to the right. 22. I'm going to have to go get smokestacks for my truck. 1, 2. And that's your answer. 22, 60. Now, if you multiply by tens, hundreds, and thousands, and you count the number of zeros, and you move it to the right when you multiply, what do you do when you divide? You move it to the left. So 3.14, which is pi, divided by 10, count the number of zeros, and that moves it 1 place to the left. That'd be 0.314. So if you didn't know that, now you do. And I teach it just about in every one of my classes. So people either forget it or they were never taught that. One of the two. There's all kinds of tricks you can learn. Okay, get back to what we were doing. What were we doing? Oh, variance. Let me go back 1 or 2 or the other way. Where did it go? Oh, Excel, thank you. I'm sorry, I forgot where I was. Okay. Now, the variance is that number, which we really don't care about that number. We care about this next number, which is equal to this number raised to the what? 0.5 power. And there is our standard deviation. So if we wanted to do 3 standard deviations equals 20. And then what do you do to the right? Add, Hubert. Thank you, class. Equals this number plus standard deviation. And we'll take it to 3 standard deviations. This number plus standard deviation. And then this number minus this. And this number minus this. And then this number minus this. So, if this was the average age of students in the classroom, I just drew you a curve.
Witchcraft.
Huh?
Witchcraft.
No, it's not.
It don't have a cell on here. It's standard time.
Okay. Now, y'all can't add, okay, 21 plus 4. What's 21 plus 4? What's 25 plus 4? What's 29 plus 4? Okay, quit acting like y'all don't know what's going on. I told y'all, the most important numbers. What are the most important numbers? We're going to highlight them. We're going to highlight them pretty color. Well, y'all just hold on a minute. Dadgum, how many questions you think I'm a woman? I can't handle but one question at a time. Dang. All right, this is your mean. Where does the mean go? In the middle. And then standard deviation is added, added, added. What do you do on the left side?
Subtract.
And that draws your curve.
Take a break.
Take a break? Dadgum.
I just don't want you to do something I need to see.
What?
I just don't want you to do something I need to see.
Oh, you need to take a break? Oh, go.
But you might do something I need to see.
I'm just going to draw this curve. That's all I'm going to do. You can draw a curve, can't you? Dadgum. What? I want some of what you drinking. What'd she say?
She said she don't drink.
Oh, dang.
I'll drink enough for both of us.
You can't. All right, that's what I like to hear. You've been drinking, buddies. I was drinking yesterday, cutting hay. Didn't run into anything.
What were you drinking?
Just dang old refreshments. Ice chest, 5-gallon bucket with ice in it. I'm partial to Blue Moon and Killian's. There you go. So, where does 95% fall? Within 2 standard deviations. So, what if I asked you, what about a person being in the class 25 years old? Normal or unusual? Normal. How about somebody that's 18? Normal. How about somebody that's 35? Unusual. Oh, be quiet. I made up this class, okay? Besides, you're 29, aren't you? Okay. Now, what if I said 35? Well, then you would say that would be a what? What would 35 be?
Outside the standard deviation.
An outlier.
An outlier.
Yeah, you're supposed to cooperate, not go against the grain. Oh. There's 35. That's outliers. And what about somebody that's 9 years old? That would be an outlier.
Why?
Because, I'm sorry.
No.
Yeah.
Lying.
7 years old.
Okay.
Okay? Somebody that's 9 years old would be what? Unusual. Unusual would fall right here.
One little category right there.
Yep. Okay, y'all got what day the test is and how many is going to be on the test. Okay, good. Let's move on. All right, what next? Who's got a question on this? Okay, what's your first question?
You accept checks for A's?
I didn't hear that.
He just explained it to me.
Huh?
He just explained it.
Okay.
Failure. This whole video.
I'm a failure. I should live in a ditch. Well, that means that I've taught them very well.
So, on the variance formula,
Yes.
the n minus 1 underneath the x minus x bar, what is that n?
N is these numbers. 1, 2, 3, 4. N is 11. That's how many numbers, how many people are in the classroom? How many grades?
Okay, and then it's minus 1?
Yeah. Now remember, your average is divided by n. Your standard deviation and variance is n minus 1. Remember that. Standard deviation, mean, you divide by just the number. Okay? The variance and standard deviation, you divide by n minus 1. I don't want you to get it confused. Okay?
One more question.
Yes?
Okay, with the bar, how do we get the 4 to go to the right side and to the left side?
That's what you calculate.
Okay, got it.
You take the square root of 18. Square root of the variance is your standard deviation. Okay? Now, look at these three things. Look at these two guys. Look at this guy. And look at this number. What can you tell me about your numbers, your data? Well, like you said, Hubert, they're all close together, so that means our data is valid. It's not sloppy. Yes, class, that's right. Y'all suck. All right, now let's throw in a couple of things. Let's throw in a 12-year-old. And let's throw in Hubert. I think I'm 48 or 49, one of the two. 49, I think. Now, what happened to those numbers? They got out of wampus. No sneezing in class. What does out of wampus mean? Well, you ever wash blankets or towels in your washer? What happens sometimes? Okay, y'all don't wash clothes.
They make the washing machine make a lot of noise.
Yes, why?
They go off balance.
Off balance. It wobble, 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 wobble. And eventually it'll cut off if you got, one of them safety do-jiggers. But anyway, it'll go wobble, wobble, wobble. That's out of wampus, out of balance. What's wrong with those numbers? They're out of wampus, they're out of balance. Why? Well, look, 19 and 22, that's the difference of what? It's the difference of 4 or 3 or 4. But look at the mid-range. It's way off. And then look what happens to the standard deviation. Instead of being around 3 or 4, it jumps to what? 10. So do we have slop or do we have tight data? Sloppy data. We have data that's all over the place. Throw another one in there. Let's throw 17 in, and then down here let's throw a 49 and a 59 in there. Tight or sloppy? Sloppy. Good. Let's throw in here a 25 and a 26. Tight. Now you're getting it. And that's how you tell the difference between your data. Sloppy or tight. And all of you feel good about yourself.
What is the terminology of the homework?
They're not going to use sloppy and tight. No, they're not even going to do that. That's just one of the things I add to the course. Being sloppy and being tight. Okay? All right. That's enough for y'all today. I've already burnt y'all's brains enough. I know y'all are like, ooh. And everybody got down to 10.